what are the different forms of data pre-processing. Okay, so the main reason for pre-processing the data is to improve the input quality so that the output of the mining, the mining results quality will be good. Okay, so yeah, and different forms of data pre-processing. We have data cleaning, data integration, data transformation, data reduction. We'll discuss each one and what are the issues in each of the pre-processing technique. The first one is data cleaning. It's also called as data cleansing. And here, this process tries to fill in the missing values. It fills the missing values and removes the noisy data. Smooth out the noisy data. And also it identifies the outliers and correct the inconsistencies in the data. So let's see how to handle the missing values. We have 6 different approaches for handling this missing data. One is ignoring the tuple. This is a simple one. Just ignore the tuple whose attribute value is missing. But this method is not effective in all the cases. It is effective only if multiple attribute values are missing. If multiple attribute values are missing, then we can go for this. So no need of keeping this tuple or record, so we can ignore it. And also in case of classification. So classification is one of the data mining functionality, right? So while performing classification, you have to train the model based on the data. So every data will be, every record will be having a tuple, class label, right? Every tuple will be having a class label. If class label itself is missing, then we can ignore that tuple. If class label itself is missing, then we can ignore that tuple from the training data. Okay. So in these cases, we can use this approach. Otherwise, this method is not efficient. Okay. And the second one is fill the missing values manually. So this method is time consuming. Finding out the values to be entered and then filling it manually. That is a time consuming approach. And the third one is using a global constant to fill the missing value. So we'll replace all the missing attribute values by the same constant such as unknown or infinity, like that, using a global constant. But this method is simple, but it is not foolproof. Means if there are many missing values and if we replace with some global constant, then the data mining program may mistakenly consider that particular global constant as some important concept, some interesting concept. And it will try to mine the patterns related to that. But the actual meaning of using that global constant is, as the data is not there, as the data is missed, we are replacing it with some global constant. So using global constant will also lead to some issue. Okay, so that is the third one. And fourth one is using a measure of central tendency for the attribute to fill the missing value. It means that we'll calculate the mean value and then fill the missing value. This is suitable for numerical attributes. For example, if you have an attribute called income, so if some of the values are missing in that attribute, in that particular attribute column, then we can find the mean of the income and then replace the missing value with that mean. So this is the fourth approach. So finding out the mean and then replacing the missing value with the mean value. And a fifth one is, it is same as the fourth approach, but based on the label of that tuple, based on the class of that tuple, we can go for calculating the mean. If the mean of the tuple for which you are filling the missing value, if the label of a particular tuple where we are filling the missing value. So we'll check that label and we'll calculate the mean for the tuples with the same label, with the same class, and then we'll find the mean. So instead of finding the mean for all the attribute values, we'll check the class of that particular tuple. If the tuple belongs to the same class as the tuple whose value is missing, then we'll find out the mean. Okay. For example, so there are customers whose credit risk is, credit risk is what we can say. Credit assessment is fair, excellent, bad, like that. Fair, excellent, bad. If there are three classes of customers in our data, and if you are filling the missing values for income, so income attribute, it's having some missing values. Now we'll check the class of that tuple, and then we'll find the mean of only the tuples whose class label matches with that target tuple. Understood? Okay. So that is the fifth approach. And the last one is using the most probable value to fill the missing value. So here we use the prediction technique such as a regression for predicting the missing value. Prediction technique, using the prediction technique for finding the missing value. That is the last approach. So these are the 6 approaches for handling the missing values. So the first one is simple, but it's efficient only in the case where many values are missing, or if the main target value is missing. In these 2 cases, we can use this first approach. The second one is filling it manually, so it's very time consuming. Third one is using a global constant. And fourth and fifth approaches are using mean or median concepts. And then these are suitable for numerical data. And the last one is predicting the missing value using prediction techniques. This is about handling missing values. And next, handling the noisy data. So noise means it's a random error in a particular measured variable. It's an error. So we have data smoothing techniques for handling this noise. One is binning. So this binning technique will smoothen the sorted data. Before performing this binning, we need to ensure that the data is in sorted order. The data is sorted. And these sorted values are divided into multiple buckets or bins. We'll divide these attribute values, sorted values, into buckets or bins. So it will be having some neighborhood values. So each bucket will be having a neighborhood values. Okay. Yeah. So binning techniques, we have 3 techniques: smoothing by bin means, by bin medians, by bin boundaries. So these are the 3 techniques. So in the first technique, each value in that bin will be replaced by mean value of the bin. This is applicable for numerical data. This binning technique will replace each value present in that partition using its mean. In smoothing by bin median, each bin value is replaced by the bin median. And smoothing by bin boundaries, for every group, for every bucket or bin, there will be a minimum and maximum value. They are considered as the boundaries of that bin, and each other values, excluding this minimum and maximum value, all the remaining values will be replaced by the closest boundary value. Either it can be a minimum boundary or maximum boundary. Each value in that bin will be replaced by the closest boundary value. We shall discuss with an example. Yeah. So actually, this binning involves partitioning the data and applying the binning technique. So for partitioning the data, we have 2 methods. One is equal frequency binning, and second one is equal width binning. Equal frequency binning means every bin will have the same number of data points. Means each bin frequency will be equal. Each bin frequency will be equal. Here there is an example of equal frequency binning. You can consider this attribute price, which is in dollars. Okay, and we need to smoothen this data. We found that there exists some noisy data and then we want to smoothen it. So for that purpose, we need to ensure that the data is in sorted order. Yes, the data is in order from 4 to 34. And next, second step is we are using the partitioning technique, which is equal frequency binning. So here we need to know either number of bins or size of each bin. Either of these two values must be known in advance to perform this technique. For example, if number of bins is decided, that is 3 bins. Now, how many data points are there? 9. So 9 divided by 3. So what will be the frequency of each bin? 3. Or if size of each bin is set as 3, then 9 by 3, that is also 3. So either of these, we need to know the bin size or number of bins. Then only we can perform equal frequency binning. After this partitioning, we got 3 bins, bin 1, 2, 3. Now we'll apply binning technique. It can be bin by means, binning by median, binning by boundary. So here I have shown bin by means and bin by boundaries. So coming to the first technique, that is smoothing by bin means, we'll calculate the mean of 4, 8, 15. So 4 plus 8 plus 15 divided by 3, which is 9. So all the values in the bin will be replaced by the mean value. Similarly, for bin 2, mean is 22. For bin 3, mean is 29. So all the values are replaced by 29. So this is smoothing by bin means. And smoothing by bin boundaries. So as we have only 3 data points and one will be considered as the minimum and one will be the maximum boundary, and all the remaining values in between these two will be replaced by either 4 or 15. As we have only 3, we have to replace only one value. For example, here, if you consider 4, 8, 15, so 4, 15 are the minimum and maximum. And coming to the one more data, that is 8. So 8 is closer to 4. Okay, 8 is closer to 4. So yeah, 8 will be replaced by 4. And similarly, 21, 21, 24. 21 is same as 21, so there will be no change. 25, 28, 34. So 28 is closer to 25. So 28 is replaced by 25. So this is smoothing by bin boundaries. This is equal frequency binning. And next, one more partitioning technique is equal width binning. Equal width. So in case of equal width, every bin have equal width with a range of each bin. The range of each bin is defined as min plus W, min plus 2W. So on min plus NW. So here W represents the width that we set. So it is calculated using maximum value minus minimum. Difference between maximum and minimum divided by total number of bins. So what is the maximum value in our example? 34. Minimum is 4. So which is equal to 30 divided by total number of bins. We need to give input as total number of bins. Total number of bins 3. If it is set to 3, then what will be the width? W is 10. So now we'll define each bin range. So what is the first bin range? Min plus W, that is 4 plus 10, which is equal to 14. Put out. Okay, so here the doubt is bin 3 is having 25, 28, 34. And in case of bin smoothing by bin boundaries, so 28 is closer to which value? Either 25 or 34. We have to find the, as these are single data points, you can find the difference between them. So 28 minus 25 is 3. 34 minus 28. What is 34 minus 28? 6. So 28 is closer to 25 or 34? Last year? Yeah, we will compare only with the boundaries, minimum boundary and maximum boundary. And all the remaining values will be replaced only with either minimum value or maximum boundary value. Is it clear last year? Yeah, okay. Yes, coming to this equal width binning. So bin 1 width is set to 14. This is the maximum value. So 4, 14 will be the bin 1 range. And coming to bin 2, what is the minimum? 4. 2 into W. 2 into 10 is 20, which is equal to 24. Okay. So its range will be after this, after 14. What could be the element? 15 to 24. So bin 2 range will be 15 to 24. And similarly, bin 3. What is minimum value? 4. 3 into width. That is 3 into 10, 30, which is 34. So what is the next value after 24? 25. So 25 to 34 will be the bin 3 range. So equal width binning will ensure that every bin will be having the equal width. So we'll set the range based on the calculated width. So width is calculated using the difference between maximum and minimum divided by total number of bins. And this is the criteria followed to set the range. Minimum plus width, minimum plus 2 into width, so on, minimum plus n into width. This n represents the number of bins, right? Okay. Yeah. First, we'll calculate the width and bin 1. This 4, 8. What is the bin range? 4, 14. So check for the values between 4 and 14, including 14. Okay, so we have only 4 and 8. So this is bin 1. And next bin 2 is 15, 24. So 15 to 24. Okay, 15, 21, 21, 24. And bin 3 is 25 to 34. Yes, we have the values from 25 to 34. 25, 28, 34. So this is one way of partitioning. This is equal width partitioning. This is equal frequency partitioning. And this is equal width partitioning. And now after this partitioning, as usual, smoothing technique will not vary. It is same for both equal frequency and equal width. We can smoothen by bin means, bin boundaries, or bin medians. So what is the mean value of 4 plus 8? So it will be 12 by 2, which is 6. So these two values will be replaced by 6, 6 using smoothing by bin means. Similarly, for bin 2 also, 15 plus 21 plus 21 plus 24 divided by 4. Whatever the value we get, we'll replace all these 4 values with that mean. Okay. In same way, smoothing by bin boundaries also. Is it clear, students? Do you have any doubts in this partitioning and binning? Okay. So this is an exercise, you can solve it. So what is the question given here? We have given the attribute age. Already the values are sorted from 13 to 17. The values are sorted here. And the question is, use smoothing by bin means. You are asked to perform smoothing by bin means to smooth this data. And the bin depth is 3. Bin depth means here, it's the frequency. Don't get confused. Bin depth means frequency, which is 3. And one information that you are not given is which partitioning is used. So indirectly they have given, right? Bin depth of 3. So we use this equal frequency partitioning. If you apply equal frequency partitioning, as the bin depth is 3. Bin depth means indirectly they have given us to partition using equal frequency. So these three, these three, these three. Okay. So how many partitions? These many. 9 bins. You will be getting 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 bins. So yeah. So after partitioning, you can smoothen by bin means 13 plus 15 plus 16 divided by 3 will be 14.67. So we'll replace each value with its mean. Similarly, 16 plus 19 plus 20 divided by 3. Mean of these three values is 18.33. Like that. Okay. You can do it. This is also one more exercise. This is for your practice. So you are given 12 sales price records. So these are prices. These are also sorted. Now you are asked to partition. This is only partitioning. You are not asked for smoothing here. You are asked to partition them into 3 bins using equal frequency and equal width. Equal frequency is also called as equi-depth partitioning. Okay, so you can solve this. If you have any queries, you can contact. Okay. And one more technique for handling the noisy data is regression technique. So this regression is a prediction technique. What it does is it will convert the given data points into a straight line form. The data will be fitted into a best line. That is this technique. And we have linear regression as well as multiple linear regression. So linear regression means it is having only, it's also called as simple linear regression. It will be having only 2 attributes, means this regression technique, the first one, simple linear regression, can be applied for the data only with 2 attributes. You can apply for 2 attributes. One attribute is used to predict the another attribute. Okay, one will be the dependent attribute and another will be the independent attribute. So this is the prediction technique actually. We'll see how this prediction helps to smoothen the noisy data. That we'll discuss with the example. And next one is multiple linear regression. So this is an extension to simple linear regression where we can have more than 2 attributes. More than 2 attributes. Okay. There may be cases where we want to analyze or predict a variable based on more than 1 variable. That's real actually. In case of that, we go for multiple linear regression. If you're going to predict a variable based on only one other variable, then we go for simple linear regression. Okay, so what is simple linear regression? It is a method that is used to fit the best straight line between a set of data points. Okay. So we'll construct a straight line. So it should be in the form of a straight line. The graph we plot must be in the form of a straight line. It should not be a parabola or any other shape. Okay. And this straight line will be used as the model to predict an unknown variable y from the known variable x. So this simple linear regression will involve only 2 variables or attributes which are called the dependent and independent variables. So the final goal of this simple linear regression is to find the best fit line for the given set of data points. We'll see this. Excuse me. We have 2 variables. This is an example for simple linear regression. We'll see how we'll construct a prediction model and then smoothen the data. Independent variable is bill amount. This is the hotel data. One attribute is bill amount and another one is tip amount in dollars, amounts in dollars. So tip amount is dependent variable and the bill is independent variable. So you are going to predict the tip. Bill will not be predicted. Bill will be based upon the customer purchase or customer ordering of the food items. Okay, so total bill, and this is amount. So we can predict the tip amount based on the bill. Okay, so this is the independent variable based on which we'll predict the tip amount. This is dependent variable. This is treated as y, and this variable is treated as x. Okay. See these values. So yeah, I have included here also. So we'll plot these points and try to create a line between those points. So what is considered in x-axis? Bill amount, y-axis, tip amount. So plot this 34, 35. 34, the 34, 5. So this one, this point. Okay, and similarly 108, second one is 108, 17. Maybe this one. No, not this one. There is 108. Yeah, this one. 108, 17, second point. 64, 11. So this is third point. 88, 8. So this is next point. 99, 14. So this one. And 51, 5. So this one. Now we have to build a line through which these points will pass. So that is our goal here. So let's see. Okay. So here there is a possibility of multiple lines, and it's not possible that every point will pass through this line, because if we consider every point passing through this line, then it will not be a line. It will be something, some curve like thing. We'll get the curve like thing. So, but we have to fit a straight line. So that is the regression model. So choosing the best fit line. The difference between the point and the line must be minimized. That is the goal. The difference between, the distance between the point that do not fall on the line must be less. Okay. So in such a way, we have to draw the line. So for that, we use a least squares method for constructing that equation. So we'll discuss this method. So according to this method, best fit regression line will pass through the centroid. So what is the centroid? Mean of x-axis, that is x bar, which is 74, and mean of y-axis, that is 10. So here the best fit line will always pass through the centroid. That is one point. Next, yeah, and now the linear regression line will be of the form, we know, equation form. What will be the equation? Straight line equation form we have learned in our school days. Y is equal to mx plus c. M will be the slope and c will be the intercept of the line. So here our regression line will be of the form b naught plus, that is b0 plus b1x. So where x is treated as independent or explanatory variable. So there are different terms: independent variable, explanatory variable, and y is dependent variable, and b0 is the slope of the line, and b1 is intercept. So these two are the regression coefficients. We call them as regression coefficients. So now we'll calculate the b1 according to least squares method. So b1 calculation is, so you can see this numerator and denominator. Numerator is, we'll find the difference between each data point of x from its mean. How much each data point is deviated from its mean. That is the meaning of this xi minus x bar. What is the difference between the actual data point and its mean? How it is deviated from its mean. So we'll do for both x and y. Xi refers to one data point. In the previous example, we have multiple rows, right? So I rows, I number of rows. x1, x2, x3, y1, y2, y3. Those are the row values. Okay, so we'll find the product of these two differences, and this is repeated for all the rows. N number of rows from I equal to 1 to n number of rows. So that is the numerator, and denominator is the square of the difference between the xi and its mean. Okay. So this is the formula for calculating this B1, this regression coefficient. Yeah. So here I have shown x values. These are x values. X is independent variable, and the predictor variable or the dependent variable is y here. So x mean is 74, y mean is 10. And now we need to find the Bill deviation, means how x is deviated from its mean. 34 minus 74, which is minus 40. 108 minus 74, 34. 64 minus 74, which is minus 10. Similarly, 88 minus 74, 14. 99 minus 74, 25. 51 minus 74, minus 23. So this is Bill deviation, and we'll calculate the tip deviation. Means how y is deviated from its mean. So 5 minus 10, minus 5. 17 minus 10, 7. 11 minus 10, 1. 8 minus 10, minus 2. 14 minus 10, 4. 5 minus 10, minus 5. Now we have to find the product of these two deviations, which gives minus 40 into minus 5, 200. 34 into 7, 238. Minus 10 into 1, minus 10. 14 into minus 2, minus 28. 25 into 4, 100. Minus 23 into minus 5, 115. So the sum of these deviation, product of the deviation, sum of the products is 650. You find the summation of all these values, you'll get 650. And the denominator is squares of x deviation. So minus 40 whole square, 1600. 34 whole square, 1156. Minus 10 whole square, 100. 14 whole square, 196. 25 whole square, 625. Minus 23 whole square, 529. And sum of these Bill deviation squares is 4206. You have to find the sum of all these values. So what is B1 now? 615 divided by 4206. Yeah. 615 divided by 4206. So which is 0.1462. So B1 is 0.1462. Okay. So, yeah. And now we need to calculate B naught. So B naught is calculated using mean of y. So B naught is, so this is the formula for calculating your B naught. So mean of y. What is the mean of y? 10. Right? And B1, just now we calculated 0.1462, and x mean is 74. So 10 minus, so do the product of these two values, you'll be getting 10.8188. So finally, B naught is 0.8188. So B1 is 0.1462. Now, what is the regression equation? B1 is 0.1462. B naught is minus 0.8188. Yeah. So what is the regression equation? y is equal to b naught plus b1 into x, which is y is equal to minus 0.8188 plus b1 is 0.1462 into x. So this is the obtained model, linear regression model. Okay. Now we are smoothing the errors in the tip amount. So this one, we are smoothing the errors in this tip amount. So y is equal to minus 0.8188 plus 0.1462 into x value. So what is the x value? 34. You solve this, you will be getting 4.1505. Similarly, the same process is repeated for all the remaining tip amounts and they will be smoothed. So 5 is smoothed to 4.15, 17 to 14.9, 11 to 8.5. Okay, like this. In this way, this regression is also used for not only for predicting, it's also used for smoothing the data, errors in the data. Okay, so this is the simple linear regression technique. And one more technique for handling the noise is outlier analysis. So what is an outlier? So outlier is an element of a data set which stands distinctly from the rest of the data. See here, if you plot the data points in x-axis and y-axis, we obtain this graph. So all the points are nearer to each other except a few points, 3 points, which are far away from this set of points. So we say these 3 points as outliers. So these outliers are the data points that lie outside all the existing pattern of distribution of data, overall pattern of the distribution of the data. So outliers can be detected using clustering technique. One technique for finding the outliers is clustering. So clustering means you are grouping the related data based on all the features of the existing data set. Okay, so here similar values will be organized into similar values will be organized into clusters. So all the other values will fall outside the set of clusters. For example, if you plotted the graph and we obtained points like this, we obtained points like this and 2 points like this. So this will be one cluster, this will be one cluster, this will be one cluster, and these two are the outliers. So clustering technique can also be used for detecting the outliers. So outlier analysis is one technique for finding out this noisy data. Yes, data cleaning as a process. So yeah, it's not a simple step. Data cleaning is not a simple step. We need to first detect the deviations and then we have to perform some transformations on the data. You are performing some transformations on the data. Okay, so the first step is discrepancy detection, means the deviations. Discrepancy here refers to the deviations. So discrepancy detection will be done and then the next step will transform the data. That is data transformation. Okay. So this discrepancy is also known as the deviation or variation. And what are the reasons for this deviation? So there are many reasons for this deviation. One is poorly designed data entry forms. Poorly designed data entry forms with many optional fields. If the input design form is not proper, then there is a chance that many fields are optional and then many fields will be missing. Data will be missing. That is one case. And another one is human errors. So while entering the data, there is a possibility of entering the wrong data. So that is the second one. And deliberate errors. Deliberate errors means the respondents, the people who are sharing their information, they are not interested to share the private information. Okay, they may not be interested in sharing their income or age, something like this. Okay, if they feel that it's a secret, they won't be revealing, right? That is deliberate errors. Okay. For example, I have asked you for feedback. So many of you have entered this feedback, but few people have just, I mean, you have to surely enter the data. So many of you have entered just hyphens. So that's a deliberate error. You don't want to write anything there. So yeah, you don't share that particular field. Okay, so that is a deliberate error. And next, data decay. Data decay means outdated data. For example, outdated addresses. I mean, the data is not of valid currently. It's not valid currently. That kind of data is data decay. And errors in the instrumentation devices. The device which record the data may be having some errors. So these are the different reasons for discrepancy. Okay. And now how to detect the discrepancies? We have two methods. One is using the domain knowledge. Domain knowledge means regarding the properties of the data. You can also treat it as a metadata, the knowledge that already have regarding the data properties, which is also referred as data about data or metadata. For example, what is the domain of the attribute? What are the possible values and possible range of values for the attribute? What could be the data type of the attribute? So all these come under the domain knowledge. Okay. And next, second one is examining the unique rules, consecutive rules, and null rules. So unique rule means we know for a given attribute, the value must be different from all the other values of the attribute. That is unique rule. For example, if you are storing, I am storing the student quiz marks. So I know every student, column, student ID column must be unique. It should not be repeated, right? If it's repeated, so some discrepancy is detected from deviation. Means student may have submitted the form twice. So I should change the form property so that they'll submit only once. So like that. So if unique rule is each value of the given attribute must be different from all the other values of that attribute. That is unique rule. Next, consecutive rule. Consecutive rule indicates that if you consider the lowest and highest value, there will be no missing values in between these two, between lowest and highest value. Best example is serial number. So if you consider the list of records, I'm having 60 records. So the last number is 60. So I'll assume that the number of records are from 1 to 60. So in between there should be no missing value. Then only I can come to a conclusion that we are having the 60 records. So consecutive rule indicates there can be no missing values between the lowest and highest value for the attribute. And next, null rule. Null rule means how to record the null condition. Okay, or null values, how to record the null values. You can use blanks or question marks, or are you using some special characters or any other strings, which replace the null values. These are the three rules which can be used for detecting the discrepancies. Okay. And discrepancy detection tools. So we have two kinds of tools. One is the data scrubbing tools and the data auditing tools. Data scrubbing tool means these tools use the domain knowledge for detecting the errors and correcting them. Whereas data auditing tools means these tools analyze the rules, unique rules, consecutive rule, and null rules. They use these tools use the rules and then detects the deviation in the data and then try to correct it. So these are data auditing tools. Data scrubbing tools makes use of the domain knowledge. Data auditing tools makes use of the rules. Yeah, this is the first step in data cleaning as a process. What is that first step? Discrepancy detection. And the next step is data transformation. So once the discrepancies are detected, now correction should be done. That is possible using some transformations. For this also we have some tools called data migration tools and extraction transformation loading ETL tools, which performs this transformation. We have a tool called Potter's Wheel. It is a publicly available data cleaning tool. It integrates both these steps, both discrepancy detection and data transformation. So this Potter's wheel is publicly available data cleaning. So this is all about data cleaning. So in data cleaning, we have discussed how to handle the missing values and how to smoothen the noisy data. And data cleaning as a process, we have two steps. One is discrepancy detection and another one is data transformation. Yeah, students. I will continue in the next class. Do you have any queries? Okay, now you may leave. Yeah, thank you. You may leave.